contact, avoid contact, 100% keen and modulation is go. 4, 3, 2, 1.
Thank you very much for this great introduction. I'm really glad to be here. Typically, I have to do a lot of traveling with long train travels or sitting hours and hours in a plane to come to the conferences that I speak of. And today, I used the cable car, the Straßenbahn, and I really enjoyed it. I'm glad to be here and to spend the next 45 minutes about .NET and .NET Core. I've been a .NET developer for far more than a decade now. And believe me, the .NET that I'm going to use today is entirely different compared to the .NET that I was using a few years ago. Because now we're talking about .NET Core. And that means open source, that means cross-platform, and a lot of other things more. And this is why I proposed this session for this conference, because there is so much to show and so much to talk about. Let's dive right into it. I have a lot of slides here, and they are already published on my blog. I will show you the URI at the end of my session again, so that you can copy it if you are interested in. I will only use some slides. Most of the session parts will be live demos, so please excuse if I'm skipping over some slides here. First, let's talk about the question, why? Why was a change necessary for Microsoft? It was really, really important for Microsoft to have .NET refactored, because .NET is a few years old, and over time, well, things start growing into directions where you possibly don't want .NET to be. So .NET Core is a complete refactoring of this established and widespread library. Why is that necessary? Well, because we have the cloud. And in the cloud, compute resources are expensive. So we need a tight framework, a small framework. We need not a monolithic framework, but we need a framework that can be stripped down to the needs of your specific application. That's one thing. And the other thing, I saw a nice comic another day ago where the father is describing to the son what clouds are made of. And he said, well, son, clouds are made of mainly Linux servers. And that's essentially true. That's also true for the Azure cloud. And therefore, if .NET should have a future, .NET has to change and open towards other platforms than Windows. And one important thing that is already mentioned here on this slide, .NET Core, a design goal of .NET Core was not to be 100% compatible with the old version, with the classic, with the full version of .NET. We have some compatibility, but I will go into more details later on. I talked about that. And the other thing is, Microsoft, under a new management team, has completely changed its genes, if you want, and turned around 100% where we had in the past a lot of IP, intellectual property, protection, and things like that. Microsoft is now developing .NET and .NET Core in the wild. .NET and .NET Core are now under the umbrella of the .NET Foundation organization. It's a foundation that cares for all the open source initiatives run by Microsoft. It is under MIT license. It lives on GitHub. They accept contributions from the community, and therefore it's really an open source platform today. What is the status of this .NET Core? .NET Core is ready for production. .NET Core is RTM for quite a while now. The RTM version of .NET Core is 1.1. The slides have a lot of download links. Just try them. And now comes the important and interesting part, and I will spend quite some minutes in demos showing the second line here, .NET Core 2.0. .NET Core 2.0 is the big thing that's coming sometimes during summer, autumn this year. .NET Core 2.0 is really changing a lot of things, and I'm going to demo some of them later on. So many companies that I know are currently evaluating .NET 1.1, .NET Core 1.1. They are already using it for small projects, but with .NET Core 2.0, the API surface will grow enormously, and therefore .NET Core 2.0, I think, will be the time when you see more and more, even from the larger existing code bases, be migrated to the .NET Core platform. .NET Core is the runtime environment, the framework, and things like that, but we also have something new, which is called the CLI. Today, everybody needs a CLI, a command line interface, so .NET has a CLI too, and the .NET CLI is also RTM. We have 1.0 currently RTM'd. It came with Visual Studio 2017, and therefore the entire stack is now ready for production. That was a very important milestone that Microsoft reached this year. The development environment for .NET Core is Visual Studio 2017, and it's also RTM. But today, I'm not going to use the Visual Studio 2017 RTM bits, but in parallel to Visual Studio 2017, Microsoft launched an important preview. The preview one for Visual Studio 2017, so Microsoft is now always publishing the RTM bits, and in parallel, immediately, a preview version that you can install side by side, and then that you can use if you want to. You have both versions of Visual Studio on your machine, and you can try the RTM bits if it's important that everything is stable, and you can go for the preview bits if you want to try things, or simply give feedback or some things like that. I'm going to use Visual Studio 2017 Preview 1 with .NET Core 2.0 Preview 1 installed, and if you have so many preview words in these products, a lot of things can go wrong in my demos. We will see whether the demo gods are smiling or not. Okay. What can you build with .NET Core? You can build, wow, console applications. Well, that's important, because console applications, CLIs, are really an important factor in day-to-day programming. Of course, you can run ASP.NET Core applications, server applications, running either websites or web APIs. Well, technologically, ASP.NET Core and console applications are the same, because ASP.NET Core is a console applications behind the scene, and we're going to take a look at that. UWP applications, you can write Universal Windows Platform applications, native Windows applications, which are ready for the store, ready for the Xbox, ready for HoloLens, and wherever you want to go to. And finally, Microsoft has now a new member in the family, which is called Xamarin, and with that you can use .NET Core to build iOS and Android applications. This is what you can build with Core. And no, you cannot build legacy applications using WinForms, using WPF, WCF on the server, and things like that. These things are not in .NET Core, they are not in .NET Core 2.0, and there are currently no plans to migrate these platforms onto the .NET Core stack. So if you have a huge user interface, for instance, written in WPF, you will have to migrate sometimes in the future. You can still use your XAML skills, you can reuse your business logic layer, but you are not going to have WPF. I'm very sorry. Or not, it depends. Okay, I'm sure you can Google that yourself. What is important? Yeah, the last one is important. The change that Microsoft is undergoing can be demonstrated quite well with Microsoft's huge support and huge investment into Docker. There is a ready-made image, Microsoft.net, not only one image, but a lot of images. And let's go there. Let's go to the Docker Hub and take a look at Microsoft.net. Here we are. And let me zoom in a little bit. Yeah, that looks good. And here you see that Microsoft has prepared for you a bunch of ready-made images, a lot of images that you can immediately use to run .NET Core without having to install the operating system and the platform yourself. And these Docker images that you see here are not only for Docker on Windows, but they are also for Docker on Linux. So if you're running a Docker cluster and you want to run a .NET application, maybe with 1.1 or with 2.0 preview, you just pull down the Docker image and you're ready to run. There are specialized Docker images for ASP.NET, ASP.NET Core, and things like that. So with that, you see, Microsoft does its best to nicely cooperate with the Docker infrastructure and the Docker community to make it very easy to run the .NET infrastructure on all platforms and with all versions. So that's important. And the other one, of course, there is .NET source code on GitHub, of course, but something that not so many people know, that there is also a URI which is called source.net. And this source.net is a nicely browsable API. So if we want to take a look at how, for instance, I don't know, system.datetime has been built, you can immediately go to this website, and this is the parsed source code from .NET Core. Of course, you can get it on GitHub, but here you have a nice IntelliSense. You can scroll down a little bit, and I can click on it and navigate to it, and I can take a look at the project structure on the left-hand side. It's really, really convenient if you just want to take a look at some of the APIs because you are not sure whether, I don't know, datetime.now or datetime.utc now is faster. Well, of course, it's UTC now, but if you want to know why, you can take a look at the source code, for instance, with source.net. Okay. By the way, Microsoft did not only change the APIs and the platform and things like that, but Microsoft completely rewrote its documentation. So msdn.microsoft.com is legacy now. The new home for Microsoft help is docs.microsoft.com. And docs.microsoft.com is built behind the scenes with, again, an open source framework, which is called DocFX, which is built on .NET Core and contains a static file generator. Everything is written in Markdown, is jacked in GitHub. You can contribute not only on the source code, but you can contribute on the documentation. You can make comments. You can search for it. It automatically generates PDFs for you if you want to download it. So give it a try, docs.microsoft.com. It's important for us as developers, isn't it? We have to read documentation, and MSDN wasn't up to date anymore, and docs.microsoft.com really is a nice way of consuming this documentation. Okay, and with that, let's go into demos. The rest of the session, the rest of the 30 minutes I have, I will mainly do demos and show you a lot of stuff. Okay, let's start. Here we are. Okay, the first one is just something to warm up, okay? Let's create a small console application, and let's start with firing up Visual Studio Preview. If I zoom in a little bit, you will see that you have on the left-hand side here the RTM bits of Visual Studio and the guy who is blinking here, but nervously, with this scratchy fillings here. This is the preview version. So you see on my laptop, I have both versions installed, and now I'm running the preview version, as you can see here. If you want to be a real developer, of course, you're always running the preview version, and well, if it dies, you switch back to the RTM bits. That's at least how I do it. Okay, let's do that one. File, new project, that one's simple. Let's go .NET Core. Let's go for here and pick a nice, let's create a new folder. Let's say this is the VS intro. Okay, here we are, and run it. And yep, you see .NET Core, and I'm hitting OK. So now we are getting a new console application. Nice. Give Visual Studio a second to warm up. Here we are, nothing special. I can run it, and it should say hello world. That's nothing special, but behind the scenes, a lot of things have changed. First, if I click here on the console app, I can here change the target framework. And the important thing here is that I have not the full framework used here, but I have .NET Core. And as you can see, I can choose the runtime that I want to be based on. Which, as I said, I installed Visual Studio 2017 Preview with .NET Core 2.0, and therefore I have .NET Core 2.0 available here. So my application is currently running in .NET Core 2.0. But you know what? I know that it's called Visual Studio, but I'm a developer and I sometimes prefer to edit config files. I do a lot of node development and I love JSON files. And therefore, Microsoft also changed something. I can immediately, here in Visual Studio, edit the CS Proj file. And this is the new project system of Visual Studio. It's not the old CS Proj files anymore that contains pages and pages of unreadable and unwritable XML code. Now that's the entire CS project file, the entire project configuration that I need for creating an executable with .NET Standard or with .NET Core. You see, I'm just specifying that I'm targeting the framework .NET Core 2.0, and that's all I have to do. If I want to change from .NET Core 2.0 to the RTM bits, all I have to change is I have to change .NET Core 2.0 to 1.1, and that's it. If I run it again, it will run based on the RTM bits. I can install them safely, side by side, no problems, exactly as I want it to have. Okay. But essentially, if you are used to Visual Studio, if you like Visual Studio, well, you have the same experience as you are used to. File a new project, a lot of visual wizards. If you want to use them, perfectly fine. If you're running a Windows box, Visual Studio is there. If you're running a Mac OS, you can use the new Visual Studio for Mac OS too, just as you like. But there are changes behind the scenes. Let me show you something. Let's do the following. I'm going to into this directory here, and now you might already know that I can enter cmd up here, and I will get a DOS command shell here. But what's new with Visual Studio with Windows 10, I can also say bash. And I'm currently here running. Maybe I will change the font a little bit so you will see it a bit better here. Now I'm running a native Ubuntu bash, a native Ubuntu unchanged kernel on top of my Windows kernel. My Windows kernel is now talking Linux to an Ubuntu where I run the native Linux shell, and from there I can do a lot of interesting things. I could install .NET Core here and so on. So we now, if we are on a Windows 10 box, we can mix and match the Linux stack and the Windows stack just as we like. Of course, I can do something else. I can, let's stay in bash, for instance. Let's stay here. And we can, of course, say Docker, for instance. If we want to, for instance, say Docker run, give it an interactive thing here. Let's say Microsoft .NET, and let's use the 2 SDK version here, and let's give us a bash shell here. Okay, so, yeah, it's empty, fine. Now I can run the .NET CLI, but this time I'm not using it on Windows, but I'm using it on Linux. Let me show you what I mean. I can say .NET new console, for instance. And that's it. If I take a look, I have my program CS. If I print it, it's exactly the same. And the important thing that really changed with .NET Core is that on Linux, in the command line, I can now say .NET Restore, which is loading all the necessary packages from NuGet.org. And then I can say .NET Run, .NET Build. Let's build it first. .NET Run would have built it too, but yeah, build succeeded. And I can say .NET Run. And now we are in an Ubuntu ready-made image. This image is provided by Microsoft. I did not have to install anything. I was using my bash, so I'm using Ubuntu on top of the Windows kernel. Inside of the bash, I used the Docker CLI, which is the native Docker CLI written in Go, accessing a ready-made Docker container, as I said, where .NET was pre-installed, and there I used the CLI of .NET Core, the command line interface, to create a new application. And if I want to find out whether I'm running .NET Core 2 or .NET Core 1.1, well, we can just say, let's take a look in the project file, and here you see we are using .NET Core 2.0, so we are using the latest preview bits on top of Ubuntu in that case. No, on top of Debian, I think. Okay. Let's try the same here with the existing application. Maybe you can remember, let me show you here, DevOne and BS Intro and Console App 1. Maybe you can remember this application. We just created it in Visual Studio a few seconds ago. I said file, new project, and so on. And this guy here is now running the .NET Core bits, the .NET Core 1.1 bits, I think. What I can do, and that's also very nice, if I, for instance, want to execute my stuff inside of Linux and run it inside of, edit it inside of Visual Studio, I can do the following. I can just open my application here in Visual Studio, and here in my bash shell, I can say docker run. And I'm going to use Docker for Windows, which is a product where Microsoft heavily contributes. What I can now say, let me first print the, yeah, here we are. I can say Docker run interactive, and now we can do a volume mapping. We can say, please mount my C drive, where my application lives, into the, let's say, app directory, make the app directory the working directory. Let's run Microsoft.NET and use the latest SDK, for instance, and give us a bash shell. So what we now have here, this application is really read from the host operating system. So this is the code that I'm currently editing here inside of Visual Studio. So I can use Visual Studio to do the programming and things like that, but I can immediately, with the volume mapping, via Windows into the Linux Docker container, into the ready-made Docker container, run it inside of Linux. I can again say .NET restore, and .NET whatever. Oh, I have started the wrong version of the Docker container. I started the 1.1 Docker container, and now I'm having a 2.0. Yeah, but I think you got the point. The important message that I want to show you is that .NET Core is really cross-platform. Run it on Windows, run it on Linux, run it on macOS, edit it on macOS and run it on Windows, edit it on Windows and run it on Linux. It really doesn't matter. You get all the things that you need to mix and match your operating systems. Of course, the same works not only for console applications, but also for web applications. Let me show you what I mean. Let's go here into this. Yeah, let's go here into this directory and again create. This time let's show it on Windows. Let's say .NET. First, let me show you something. Let's say .NET info. If I run the .NET CLI, by the way, Visual Studio is using the .NET CLI behind the scenes too. If I run the .NET CLI, it always takes the latest version of the CLI that I have on my machine. But in my case, I told you that I have installed the .NET 2.0 bits, and as you can see here, if I run .NET Info, it tells me that I'm now running the .NET Core 1.0. Why is that? Well, you have the control, because there is a special file which is called global.json that you can put somewhere in your directory tree. So .NET will look at it in your current directory, then a directory up and up and up. It will look for this global.json, and here you can ask .NET to switch to the proper CLI. So if you want to have one project where you have the latest, greatest stuff, the things that the cool kids on the block do, the .NET 2.0 Preview 1, and on the other project, which is maybe more critical, you want to have the RTM bits, absolutely no problem, just place this global.json and you are perfectly fine. Visual Studio will respect it, Visual Studio Code will respect it, the .NET CLI will respect it, you're perfectly safe. So in that case, I'm now running the existing, the RTM versions of the .NET CLI. And with that, let's say .NET new web. And let's choose the framework, the .NET Core App 1.1 framework. OK. So, OK. Here I now created new web applications. Let's quickly build it, restore. It will fetch the NuGet packages. OK. And let's run it. Let's change something. Let's start Visual Studio Code. By the way, if you don't use it already, Visual Studio Code is Microsoft's cross-platform open source development environment. I fell in love with it for C# development and for Node development. In this case, I'm just saying, please listen to port 5000, because I will need that one for a later demo. It's fine. .NET build. Hopefully everything is fine. Let's see. Nope. Yeah, of course. S. I was missing an S. Okay. Fine. Okay, let's run this guy. And now it's listening on port 5000, and now I should be able to say localhost 5000, and it should say hello world. Yes, works perfectly fine. Of course, I could show you this sample on Linux and so on, and I'm going to show you this sample on Linux. But this time, I'm not going to run it on Docker, but I'm going to run it on a Linux host in the cloud. Why? Because I want to show you remote debugging. This is also a capability that .NET Core has. You can run the .NET Core runtime on any server, Windows, Linux, wherever, and it's very simple to just attach to this server, even if it's running Linux from within Visual Studio. Let's try that. For that, I have created a small Linux server here in the cloud, and of course, now I have bash. I will SSH into this server. This guy, I think it's running in Ireland, in the Azure data center in Ireland, and it has also installed the .NET CLI. So it's very simple. You can now install the .NET runtime using apt-get. So there is a package repository that you can just add to your Ubuntu, Debian, whatever Linux flavor you want to have, and then it's just an apt-get install, and you have .NET on your Linux machine, for instance. And with that one, I'm going to use Filezilla here to copy my application. So the host, let's copy the IP address. Here it is. Let's copy it. Let's enter my password. OK, let's see if it works. No, could not connect to server. Let's try it again. Probably. Yeah, very good, very good, very good. OK, here I already created this directory, and here I also have my directory locally. Let's quickly go to DevOne here, and here, oops, here it is. And yeah, that's exactly the application that we created a second ago. So in this case, I'm just copying my files onto my Linux server. And on that side, let's go into DevOne, and let's go here, and here we are. Yeah, perfectly fine. So now what I want to do here is I want to start this application on my Linux box. No problem. I can say .NET restore. We already know that. OK, let's say .NET run. It's building the guy. And then hopefully it will come up. And with that, I can say, let's take the IP address here, that one. IP address with 5000, and if everything, yeah, perfectly fine. This is now running in Azure on a Linux server. This is a web application in Azure on Ubuntu. I don't know which version. I've forgotten what I installed here. But the important thing is that I go now back in my Visual Studio. And in Visual Studio, I open exactly the same application. OK. Here it is. OK. Here is my startup. And let's put a breakpoint here. Here it is, F9. And then say debug attached to process. And the nice thing is that Visual Studio 2017 can now use SSH to SSH into my Linux server in the cloud. So let's use that one. And again, the IP address, I forgot it now. Here it is. the IP address, and let's try. You see here, now I see the processes on my Linux box directly in Visual Studio, and I can select the .NET Core application running in the Linux cloud to do remote debugging. Attach it, use the Manage Debugger, and now let's crossing fingers that internet will work. Here we are. Let's go here and hit F5, and here we are. Running Visual Studio Preview on my local box, remotely debugging a Ubuntu machine in the Azure cloud, running .NET Core application with a web backend, and I'm sure you can imagine that this is really nice if you have a larger application, and of course, it will never happen for you. Sometimes I make mistakes that only happen in production. Has that ever happened to you? Well, it has happened to me, and therefore it's sometimes really, really convenient to have the capability of doing remote debugging. You might even ask yourself if that will work with Docker too. Well, with Docker, it's even simpler. With Docker, we can do the following. With .NET Core 2.0 and the latest bits of Visual Studio, I can right-click here and just say Add, and just say Add. Okay, I should be able to say Add. I know what. Sorry. I have to create it in Visual Studio because otherwise I have to enter some settings files that I don't want to do here on stage. Let me quickly regenerate the app and use the .NET Core, I don't know, 2.0, and here you see it. You can immediately, when you create this application, configure it for Docker support. And what Visual Studio will give you, it will generate side by side to your .NET Core application a Docker file and a Docker Compose file. So now I have another application, another web application, but this time I have a ready-made Docker file generated by Visual Studio, and I have a Docker Compose file generated by Visual Studio. And now I can click here, debug on Docker, and what's happening now is I'm really doing the Docker build, the Docker Compose up inside of Visual Studio. It will start, if everything goes right, it will start the Docker container in my Docker for Windows. It will attach the debugger automatically, and this works for multi-container applications. So if you have a microservice infrastructure where you have a solution consisting of 5 web APIs and you all edit them inside of Visual Studio, that's perfectly fine. And here we are, you see, hello world. This is now running inside a Linux Docker container. I can prove that to you. I can say Docker PS, and here you are. Here you see, this is the Docker container that Visual Studio created for me. And let's set the breakpoint here, and let's hit refresh. And here we are, inside of Visual Studio, Docker, deployment, build, run it, and debug it in a multi-container infrastructure. That's really a huge step forward in productivity when it comes to building microservices based on .NET Core 2.0 with Docker support on my Linux machine, on my Windows machine. I'm very sorry. Okay. So lots of demos, and the final takeaway is, I showed you that one, I showed you that one. Yep, I'm fine. The final takeaway from this part of my session is, yes, .NET Core is capable of playing well in this whole open source Linux Docker infrastructure. That is the point that I wanted to prove with this demo. So let's go on and let's use the final 15 minutes or so that I have with another demo or with a set of other demos. And these demos are now about standard libraries because the sister or brother of .NET Core is .NET Standard. What Microsoft essentially did is they said .NET Core is just one flavor of .NET. There is also this .NET Full framework, and there is Xamarin, and there is UWP, and there is Mono, and there are game engines, a lot of different flavors of .NET. It would be super useful if it would be possible to have a standardized API And those guys who write libraries can write these libraries against this standard, and the different flavors of .NET can support these standards. So this would really be a huge step towards reusable software. And this is exactly what .NET Standard is all about. The .NET Standard is a set of NuGet packages with empty implementation, just defining a standardized API with a certain version number. And different flavors, you see it here on the left-hand side, different flavors of .NET can then say which version of the standard, you see it up there, they support. You see? And what you see here is if you run a .NET Standard application, if you create a .NET Standard application with .NET Standard 2.0, this standard library can immediately be used from .NET Core on any platform, but it can also be used on .NET 4.6.1, and that's the important thing. So if you currently have a .NET application and you stick to 4.6.1 because of WPF, for instance, there is absolutely no problem that you rip out some business logic pieces and convert them into a .NET Standard library. You can still use it from your legacy WPF application because 4.6.1 supports .NET Standard. But you are also ready for the future, ready for Linux, ready for Xamarin, ready for the Xbox, ready for the HoloLens and whatever you want to have. That's the idea of this .NET Standard thing. What you see here is the matrix showing the different .NET flavors on the left-hand side and their support for .NET 1.6, 1.4, 2.0, and so on. So let me show you what that means with another short demo. Let me quickly create a new application, and this time I'm going to create a class library. And the point that I want to make here is, here you see I can create a class library based on the .NET Standard. If I do that, I can again select which version of the .NET Standard do I want to target, and therefore the API surface changes. If I target 1.6, I have other APIs than if I use 2.0. Of course, that would be too simple. What I also can do, and that's brand new with .NET Core 2.0, I can use existing 4.6.1 libraries, existing business logic that you already have built and where you have the existing DLLs, not the source code. And with .NET 2.0, in contrast to 1.1, you can now reference existing binaries from .NET Core as long as the existing binaries just use APIs which are part of the appropriate .NET Standard. So you can use an old library that you compiled 4 years ago with some business logic in it, and you can just use it. Let me show you that with an existing project that I have prepared for this talk, and this will be my last demo. Yep. What you see here is I have a full framework library. You will see that immediately if I open up the library here. It's 4.6.2, you see that one? And now I can create, for instance, a .NET Core console application, and I can say add reference. And the important thing here is that from my .NET Core 2.0 applications, I can now reference .NET Standard libraries, and I can reference existing full framework libraries. So the whole point of this .NET Core 2.0 is that Microsoft is adding a huge bunch of APIs. They're adding multiple thousands of APIs. I think 20,000 additional API calls are added to the .NET Standard for version 2 compared to version 1.6. And additionally, they add a so-called compatibility shim that you can use .NET Standard from full framework and core, and the other way around. You can use existing full framework libraries from .NET 2. And now the important part comes, this works also on Linux. So you can use a 4.6.1 DLL. You reference it from .NET Core, you copy it to Linux, and it will simply work. That's the important thing here with .NET 2.0. So compatibility is the important thing here. With that, I want to summarize. What is the state of the union with .NET Core? No question, C# and .NET are very popular. If we look at Stack Overflow's most used and most wanted technology, it came out a few weeks ago. We see C# in the top 10 most used, and we see C# in the top 10 most liked. That's nice. .NET Core is definitely the way to go for the .NET developers, and .NET Core is RTM, so you can use it for production workload, but .NET Core 2.0 will add a lot of things, and it will make migration much easier. The platform coverage has already been extended, so you can use macOS and various flavors of Linux. And with .NET Core 2.0, it's even getting larger. We get Raspberry Pi support and things like that. And finally, ASP.NET Core shows really good performance. Take a look at this URIs, and you will see that it really outperforms, for instance, Node.js on various platforms. And the tooling, as I've shown you, is really great with Visual Studio 2017. There are a few edges if it comes to performance, profiling, and things like that on Linux. We're not finally done there, but, well, it's improving. It's really improving. So, if you ask me, .NET Core is ready for prime time. I love writing Node.js, for instance, but on the server side, to be honest, my favorite platform is still, or is again, .NET, because of the flexibility that .NET Core has brought to this platform. I hope that everybody in the audience has seen something new, maybe has a new impression of .NET Core. I want to thank you for the opportunity to be a speaker here on stage. And I want to wish you a very nice DevOne for the rest of the day. And I say, yeah, thank you. That's it.
Wow. All right. Amazing. So I think we have time for one question. Anybody? Otherwise, Rainer will be outside.
There is one.
All right. Now I have to run. I'm the one with the microphone.
You only take one question because you don't want to run.
Yeah.
So you said you can reference libraries that are written in the full framework.
Yes.
But can you also run a completely full framework binary exe on .NET Core?
No.
Okay.
No, the executable, the entry point, has to be .NET Core, but you can reference .NET Full Framework class libraries. I highly encourage you to use the API port tool, which is linked in my slide deck, to check whether your class library is compatible or not. And if this tool says, thumbs up, it's compatible, feel free to use it. But the entry point must be core.
Okay, thanks.
All right, thank you. So a few closing words for this session from my side.